Why is it that we can ask him why it is that changing?
Try to look at the web as I do this. Just go down to the
Yeah.
do you know the answer though? Like animations or something there. Are you still loading? This page takes forever to load. Scroll up. Okay. So that's just powering on. Okay, so these, by the way, you can stop them and step through. Like one at a time, right? Okay. So this is what I'm suggesting everyone use for the function generator. So this is the waveform generator, but we don't need this anymore because this one has a built-in, which is very nice. That's why I decided to do all this. Alright, so to do this, I'm going to start now. Did you want to record? Alright. So the first thing is these buttons both enable and disable, right? But they also bring up the menu for that particular thing. So it's like a dual purpose there. So that's why I say, do that, and the softman, this GUI will come up for this part, and then we can control it. So this is for the waveform generator, right? So the first thing is to press this button and select square wave. Then we want 5 volt, so we press that. So select the amplitude. It should just be on amplitude, and then you can it shows this little turning symbol to indicate that this knob will change that. So we just want 5 volt peak to peak because we want a 5 volt square wave. And then because we want it to go from 0 to 5 rather than negative 2.5 to positive 2.5, it should have a 2.5 volt offset. So because otherwise it'll be centered around. So that's why I come here, press that, and then the same thing. You just start turning that until it's 2.5. So that's the first one. Now nothing's displayed because we haven't measured it yet. So then this gets plugged in here. And I guess they shouldn't connect it and turn it on to their circuit until their circuit's powered up. But I've already powered my circuit, so I can go ahead and connect that. It should be fine. Alright, so I have it going to input A. There. And now I want to measure it. So the big thing I like people to learn when they're testing their code, testing circuits, is don't just measure the output, always measure the input and then work your way to the output. Alright, so for this thing, all we have to do is make sure it's on. So it's on. I don't remember if there's much else to do. It just gets connected there. Students may forget to connect this, because once you connect this, you can already see something, but the proper thing to do is to always connect it to ground. You know what I mean? Okay. Oh, I didn't turn on the waveform generator. Okay. So this turned on the waveform generator, and now I'm also measuring it. This is connected here. It's the same thing. This is the input to the circuit. I have this wire going to there. Okay. So this is the input to the circuit. All right. So the first thing is that you can stretch in time by using this, and I can stretch enough that I can actually see the transition. I can turn it the other way, like that, right? So I'll put it back to this, right? And then the next one is to connect the second. Oh, I forgot one thing. So that to reset the scope, this is the default setup. So we start from there.
That we know the answer to.
So start with that. Okay. Now again, I can do this, but it's not synchronized, so we have to set up the trigger. Sorry, I'm going out of order. The recording is going to be messed up. Okay, but to control the trigger, I forgot that this is the one I used earlier, so I'd already had the correct settings. That's what the problem is. So I should have reset it. So everyone should do that. Always reset it. Otherwise, they'll be starting from different places, right? All right. So we're starting over now. Default setup. Turn that on. Then this is how we control the sync. So I'm going to press the trigger button.
We can solve that.
All right. Now, the order doesn't matter, but the first thing is the trigger is set at 0, which isn't useful because we have the waveform going from 0 to 5. So the first thing, or second thing, I don't know which, but I'm going to go ahead and change the trigger type to edge, and then I want the slope for this lab. I want the slope to be negative. So I'm just going to press that twice, and it goes to, sorry, falling edge, not negative, but falling. Right? So that's done. There's nothing else. You can also see there that that symbol changed to falling. So if you look at people's oscilloscopes, you can always see that that's showing falling, right? All right, so it's trying to synchronize the display to the falling edge, but it's at the wrong level. So you can change it either by this knob, and notice it's changing the trigger level, but for the sake of the lab, I told everyone just press this button, and it automatically goes to the 50%. So we just press that. I just pressed that, right? And it goes to the 50%.
It's a trigger push for 50%.
Yeah.
What does the switch do?
So that's it. So now I can zoom in and out, as I showed you before. And we're now measuring the waveform generator is now going to channel 1. Okay? All right. So the next part is to measure.
I like that question.
The first sort of half,
So what is it?
not first half, the first part of the circuit is inverters. So there's just 3 inverters. For the sake of the lab, we could use 1 inverter, but I found if you use 3 inverters, it slows down the signal more, so it makes the result easier to see. So that might be confusing to students. You don't need 3 inverters, but it's easier to see the time lags when you have 3.
The glitch is obvious.
Well, not even the glitch, but even like the delay that we're going to show. So this is the 3 inverters. So the first thing I said is before you go and measure the whole circuit, you should measure the inverted signal. So again, ground clip, always. And then I'm going to go ahead and clip that onto there, right? Now I want to enable channel 2, so I'll press that button, and now channel 2 is there. And then the only next thing is I can immediately go to the vertical shift. Where is it? It's there. Right, so now I can just shift that down. Now it's there.
Do you know why?
So in the lab I say go to -10, so that's right there. And notice it's showing the offset there. Right?
No, I'm
Okay.
Why?
So we'll notice that because it's going through 3 inverters, it's inverted. Okay. Now, what can't be seen at this scale is that one is actually delayed from the other. So if I turn the horizontal knob, and again the time per division is changing, so the time per division, I'm changing, that's displayed right there. It's changing. So there I can see that there's actually a decent delay between when input falls and when that inverter rises. So now we have A and A invert with there's a delay between them. So at this point, if the circuit is correct, I should be able to measure the first output, and there's a glitch. So that's showing the glitch. That should never be there because it's supposed to be going from the transition going from 1 to 0. The output should be 1, but then the truth table says even when this is 0, it should still be 1. Right. So if I zoom out, it looks like it's just 1, but in reality, there's a glitch there. Which the reason this is a problem because if I have this connected to like an active low reset asynchronous signal in the system, it'll respond to that, which is bad. So if you need a glitch-free circuit, then this is bad. I could not send this signal to like a asynchronous reset, active low reset in a flip-flop. Okay, so the next part of the circuit, I pulled that out. So then put that back in. So the next part of the circuit is finally just probing the glitch-free version, which is there. I guess it'd be useful to show. I was turning.
Well, no, I mean, that's the thing, I changed JL.
It might be useful to show. So the other two, so this is A, and then B and C I just have tied with wires. But if I change those to the other position, So, like for instance, they're showing now with C low that there is a difference, and both of these glitch and glitch-free versions should be the same, and they are. But the only difference is that there's a specific condition when both of them, B and C, are high, and A is going from 1 to 0, that the glitch occurs in one and not the other. So that's what the lab is.
Keep it out for now.
So I keep going on the labs, right? You can see it more. Okay, so I'll leave that there. Is there any questions about this? I am concerned about if the students will finish.